You are listening to The Vocal Technologist. Spoken tech for your ears.
A coding tool uploaded an entire private repository, unredacted, straight to a cloud bucket. We should probably talk about that.
Yeah, I mean, that is just the kind of security nightmare that keeps enterprise IT departments awake at night.
Oh, absolutely.
But honestly, it represents the exact growing pains we are seeing across the entire industry right now as these systems actually start acting on their own.
Yeah, I reckon it is a good time to get into another session of Vocal Technologist.
A lot.
We're going to have a proper look at how AI agents are moving from, simple text boxes you just type questions into, to autonomous systems that are running our code and navigating the open web and genuinely taking physical form.
Which is a huge leap.
It really is. So we're pulling from XAI's security logs, some leaked memos on OpenAI's codex strategy, and this wild new hardware paper from Sakana AI to pick all of this apart.
Because that leap from a chatbot just generating text to an agent taking action on your behalf, it is staggering. You're giving a system agency, and with that massive increase in capability comes a, frankly, terrifying increase in complexity.
Yeah, it's like we're handing these systems the keys to the castle.
Exactly. And we're just starting to figure out the mechanics of what that actually means. Which
brings us straight back to the dodgy upload from earlier, because I want to nut out exactly what happened here.
Yeah, let's get into it.
So the details coming out of XAI's official Grok build command line interface, they show that it transmits the contents of the files it reads verbatim.
It's completely raw.
Completely raw, no redactions. It just grabs whole repositories, regardless of what the agent actually needs to read to do its job, and dumps it all into a Google Cloud storage bucket.
Which sounds insane on paper.
It does. If I run an agent locally on my machine, how is it acceptable that it just grabs the entire code base?
I know. It
is like hiring a plumber to fix your sink, and on the way out, they take photocopies of your diary.
That is a great way to put it, yeah. But here is the problem. Your plumber physically needs to see the pipes to fix the sink, right?
Sure.
In software, an agent needs immense context to understand a complex code base. If you ask an agent to fix a bug in a specific file, that bug might actually be caused by a dependency in a completely different, undocumented folder.
So it's just flying blind otherwise.
Exactly. So the brute force engineering solution is to just feed the agent the whole repository, so it would have the context it needs to even start reasoning.
The security implications of that are just a bit ordinary, though. I mean, if a system is just slurping up everything indiscriminately, that completely breaks the concept of zero trust security.
Oh, it shatters it entirely.
Yeah.
Zero trust assumes a breach is always possible, right?
Right, so you verify everything.
You verify every single request. But agents operate at a speed and scale that totally breaks those human-centric security frameworks.
Wow.
They're not human, but they're not traditional deterministic machines either. They make unpredictable decisions.
Yeah, so if an agent has persistent, broad access to your entire code base, a single hallucination.
Or compromised prompt, yeah.
Yeah, right? It could leak highly sensitive intellectual property just by accident.
It's a massive vulnerability. But you cannot just tell developers not to use the tools because the productivity gains are too huge.
So you have to change the environment the agent actually operates in.
Precisely.
Looking at what Perplexity AI is doing with their space platform, they are creating ephemeral sandboxes.
Yes.
I am guessing that means they aren't just giving the agent a guest pass. They are essentially locking it in a digital escape room, handing it the tools for one specific micro task, and the moment the task is done, the entire room is incinerated.
Mechanically, yeah. That is how they're solving it. When the Perplexity agent needs to handle sensitive work, space spins up that isolated sandbox. It uses control plane layers to isolate credentials.
So the agent never actually sees the password.
Exactly. The control plane acts like a completely separate neural pathway. The agent wants to access a secure database, but it does not get the password. Instead, it asks the control plane. The control plane checks a node-level service, verifies the exact microtask, fetches the necessary data, and then hands it back.
Ah, so the agent gets exactly the access it needs for that specific micro task and leaves no persistent access behind.
It's completely isolated.
So we are having to invent entirely new security architectures just to babysit the agents.
Basically, yeah.
And it is not just about protecting code from the agents themselves, is it? It is about protecting trade secrets from other tech giants.
Oh, the corporate espionage side of this is wild.
Right, like Apple is currently suing OpenAI and former Apple executives, alleging they bypass security procedures to steal confidential hardware information.
And notice the specific target there, hardware information.
Yeah, not software.
Apple alleges this was to support OpenAI's own device ambitions.
Hmm.
It really highlights how physical hardware and edge computing are becoming the critical bottlenecks for these AI labs right now.
And the competitive tension is just unprecedented. I mean, it's driven entirely by the financial stakes.
Which are massive.
The scale of the money is just hard to wrap your head around. Anthropic is reportedly lining up meetings with Goldman Sachs and Morgan Stanley for a mega IPO, following a funding round that values them at a staggering $965 billion.
Nearly $1 trillion.
That surpasses OpenAI's valuation of $852 billion.
And you can see the internal pressure that creates. OpenAI is rapidly consolidating power under co-founder Greg Brockman, basically tasking him with driving revenue in the face of this exact competition.
Because they're gearing up for their own prospective IPO, right?
Exactly, to maintain their market position. The pressure to justify almost trillion-dollar valuations means you just cannot afford a single leak of proprietary technology.
Or to lose the talent war, for that matter.
You cannot afford it.
It feels like a high-stakes footy trade period. You have these massive clubs poaching principal engineers and buying up smaller startups, but the stakes are trillion-dollar market caps, and national regulators are acting as the umpires.
That's a perfect analogy.
Look at Tencent. They are trying to swoop in and buy an agentic startup called Manis for $2 billion.
Which is a huge sum for a startup.
And they're only able to do that because regulators stepped in and blocked Meta from acquiring them first.
Yeah, Meta recognized the value of Manis's agentic technology early on, but the regulatory environment is incredibly strict regarding tech consolidation right now.
So Meta gets blocked, and Tencent just walks right in.
Once that deal was unwound, Tencent stepped in for the exact same $2 billion valuation.
Why are they so keen on it?
Tencent wants that technology to build an agent that can run errands across their entire massive ecosystem.
Wow. So if you are listening to this on your phone, imagine a single agent that can seamlessly navigate your banking app, your messages, and your calendar without you doing a single thing.
Yeah, all autonomously.
For a company with 1 billion+ users, an autonomous agent that can navigate their super apps is definitely worth every penny of that $2 billion.
It is. But to actually justify those eye-watering valuations overall, these AI labs have to prove their models can do cost-effective, reliable work for normal businesses.
Right.
They have to make the math work, which is currently the hardest problem in the field.
Because compute is expensive.
Extremely. Everyone talks about model routing as the solution.
Right. The idea that you just dynamically send simple questions to a cheap model and hard questions to an expensive model, like, why pay top dollar if you just want the agent to format a spreadsheet?
Exactly. But the illusion of model routing is that it is just a simple selection process, like picking off a menu.
Right.
In reality, it is a brutal systems optimization problem. When you are running these agents in production, factors like caching, the interactions of different workloads, and the serving infrastructure itself often have a bigger impact on your overall costs and latency than the base price of the model.
Right, so let's look at what Cognition just did with their coding agent, Devin. They swapped out their underlying model, moving from Opus 4.8 to a new model called Fable 5. I saw the numbers on this, and Fable 5 costs twice as much per token as Opus 4.8.
Twice as much.
But Cognition claims that by using the more expensive model, Devin's overall bill actually went down, while its benchmark scores went up. That sounds like they're having a lend. How does that work?
It comes down to agent behavior. If you have a cheaper model, but its reasoning is flawed, it might require the agent to take 20 steps to fix a single bug.
Okay.
So it generates thousands of tokens of trial and error along the way, and you pay for every single one of those tokens.
Oh, I see.
Fable 5 might cost twice as much per token, but if its reasoning is so much sharper that it finds the solution in just 3 steps, your total token usage plummets.
It is like buying a ridiculously expensive high-end oven that cooks perfectly in half the time, so you actually end up saving money on your power bill.
That is exactly it.
You pay more upfront for the capability, but the efficiency makes it cheaper to run.
You are optimizing for the total cost of the workflow, not the unit cost of the token. And OpenAI is taking a slightly different approach to the same efficiency problem with their codex strategy.
What are they doing?
They are explicitly splitting tasks across specialized variants of their GPT 5.6 model.
Oh, right. Hey, if you are keen on how we untangle this stuff, just drop a subscribe on whatever app you are listening on. We love breaking down these systems. So with Codex, they have segmented the model into Sol, Terra, and Luna.
Yes, 3 distinct tiers.
I am guessing they are treating intelligence like a manufacturing pipeline so they don't have to use their lead engineer to sweep the floor.
Mechanically, that is exactly how it operates. GPT 5.6 Sol is reserved for ambiguous, high-value problems where you need deep reasoning.
Okay.
Terra handles the everyday, straightforward implementation logic. And Luna is designed for fast, tightly bounded tasks where speed is the absolute priority.
That makes a lot of sense.
They even have a Sol Ultra mode that adds deeper multi-agent coordination, allowing multiple instances of the Sol model to critique each other's work for the most complex problems.
And the sheer volume of data these agents need to process requires a completely different memory architecture, too.
Absolutely.
Moonshot just launched Kimi K3, which is a 2.8 trillion parameter model with a 1 million token context window, specifically optimized for agentic coding.
1 million tokens is massive.
1 million tokens means you can drop entire libraries of documentation, massive code bases, and hundreds of error logs into the prompt all at once. The agent does not have to search for the context, it just holds it all in memory.
But splitting tasks and expanding memory creates a new problem.
Which is?
If an agent is writing thousands of lines of code and coordinating across multiple models, how do we know it is actually getting smarter and not just cheating the exams?
Oh, right.
This is the evaluation crisis.
Yeah.
The benchmarks we used to test AI a few years ago are completely useless now because the models just max them out. Researchers are having to invent entirely new ways to evaluate autonomous behavior.
And that's where Prime Intellect comes in, right? They just released their verifiers V1. They decompose the testing environment into 3 distinct parts: a task set, a harness, and a runtime.
Yes.
So instead of just grading the final output, I'm guessing that means they are actually putting the agent in a secure environment and watching its every move?
Exactly. They are testing complex, multi-step agentic tasks at scale. The task set is essentially the syllabus.
Right.
The runtime is the secure physical desk they sit at, an isolated operating system. And the harness is the invigilator walking up and down the aisles.
That's a great visual.
So instead of asking a model a multiple-choice question, you drop it into that secure runtime, give it a complex goal, and the harness monitors exactly how the agent interacts with the operating system to achieve it.
And if it messes up?
It resets the environment if the agent breaks anything.
Wow. Testing actions, not just words.
Exactly.
And there is another evaluation tool called Schema that forces frontier models to act like physicists to pass the ARC AGI-3 benchmark. The ARC benchmark tests pure reasoning by giving the agent a game environment with absolutely no explanation of what the agent is looking at.
No instructions at all.
Right.
So schema forces the agent to observe that silent environment and then write an executable program that models the underlying mechanics of the game.
So the mechanism is hypothesis generation and reality testing.
Yes.
The agent forms a theory about how this unknown universe works, writes code to simulate it, and then tests its predictions against the actual game.
And if its simulation matches reality,
It proves the agent genuinely deduced the rules from scratch. It cannot memorize the answer.
it has to reason it out.
Yeah.
Which leads to the single most mind-bending piece of research in the stack.
Oh, I know what you're going to say.
Researchers have achieved genuine, recursive self-improvement.
Yes. They took an auto research agent and essentially set it to run on itself for 8 days.
8 full days.
A fully autonomous system with an inner loop optimizing code and an outer loop optimizing the harness that tests the inner loop.
The inner loop writes the code, while the outer loop acts as a brutal manager, constantly rewriting the test the inner loop has to pass.
Wow.
And by playing this game of cat and mouse for 8 days, it discovered inefficiencies human engineers totally missed.
Incredible.
It beat a harness that researchers had spent 2 years hand-tuning. It autonomously designed a completely novel search algorithm. It built a layered defense system against reward hacking.
Wait, reward hacking, that's when the AI finds a lazy loophole to get a high score without doing the actual work, right? Like pausing a game indefinitely so you never technically lose.
That is the exact mechanism.
Right.
The agent learns to exploit the measurement rather than actually solving the problem.
Right.
But the outer loop in this research recognized the inner loop was trying to reward hack and autonomously built layered constraints to force the inner loop to actually do the hard work.
That is insane.
And the most fascinating result of this entire 8-day cycle, it reduced its own prompt size by 16 times.
Wait, really? It reduced its own operating instructions by 16 times?
16 times smaller, yeah.
When human engineers try to make an AI better, our instinct is usually to give it more instructions, add more rules, write a longer prompt. We try to over-explain.
But when this AI was allowed to optimize its own architecture over thousands of iterations, it realized that those massive, complex prompts were creating inefficiency. It systematically stripped away the noise, distilling its operating instructions down to something 16 times smaller, but vastly more effective. It became significantly better at optimizing its own code than the human researchers who originally built it.
It figured out how to be elegant.
It did.
And while these software systems are optimizing themselves in the cloud, we are seeing autonomous systems literally break out into the physical world.
Which is the next frontier.
Software agents managing code bases are impressive, but Sakana AI just introduced smart cellular bricks. We are literally talking about physical hardware bricks equipped with neural networks.
Physical blocks equipped with the ability to communicate locally with the bricks immediately next to them.
So cool.
There is no central server telling them what to do. There is no master blueprint in the cloud.
So how do they actually communicate and build? It is localized neural networking, right?
Yes.
Imagine each brick is a single neuron. It only knows what the immediate neighboring neurons are doing. It doesn't even know the rest of the structure exists.
And through that decentralized collective intelligence, they can autonomously classify and reconstruct 3D shapes. They work together to build structures entirely through local communication.
That's wild.
Contrast that with traditional swarm robotics, which usually still relies on a central hive mind to coordinate the drones. This has no hive mind.
It's completely independent.
Yeah. The experiment showed that the system is incredibly robust against module failures. If a few bricks fail or get knocked away, the local network adapts and the surrounding bricks continue the reconstruction. It is biology applied to hardware.
So we are literally talking about physical blocks that know what they're supposed to build, and they can arrange themselves to bridge a gap if you knock a few away.
Exactly.
That is completely wild. And it's not just experimental bricks either. The big players are building the infrastructure for physical agents right now. NVIDIA just expanded its Jetson Thor modules, the T3000 and T2000, powered by their new Blackwell architecture.
Those modules are specifically designed for edge robotics and visual AI. They bring massive compute power directly to the physical robot, removing the need to constantly beam data back and forth to a cloud server.
Which solves the latency problem, doesn't it?
Exactly.
If a robot is walking down a flight of stairs, it can't wait for a server in another country to process the visual data and tell it where to place its foot. The lag would cause it to just fall over.
You need the agentic intelligence running locally on the edge.
And the industry sees this trajectory. These NVIDIA modules are already being adopted by massive robotics companies. Boston Dynamics is using them. Amazon Robotics is integrating them into their logistics networks.
We are moving from centralized cloud intelligence to decentralized, localized hardware, acting autonomously in our physical spaces.
It really paints a vivid picture of where this is all heading. If you are a developer listening to this, you might be wondering if a model like Devin or Kimi is going to replace your junior team next quarter.
A lot of people are asking that.
The reality is the shift is much broader than just writing code faster. We started this...
The velocity of this space is moving faster than our ability to easily categorize it. While the majority of the tech world is distracted by chat interfaces on screens, arguing about which text model is slightly more articulate, the massive leap is quietly taking physical shape in the real world.
So next time you see a pile of bricks on a job site, wonder if they're about to organize themselves. But it leaves you with a much bigger question. Once physical infrastructure can build and repair itself without human blueprints, who actually owns the rights to the physical structures being built? Vocal technologist, see you soon.
Spoken Tech for your ears.